Hi, we're going to talk about 3-4 today, systems of equations in three variables. We're going to talk about the ordered triple versus an ordered pair, systems in three variables, what a system with one solution, how we would figure out if it has one solution, and how to figure out if they have no solutions or infinite solutions. So first off, an ordered triple puts us into three dimensions. So we're talking about we have an x coordinate, a horizontal, a vertical, and then another part that comes out the page. If you were trying to actually draw a graph of this, all right, you'd go your x and y coordinate or axes go like that, but then you would have a z axis that comes out of the page like that. So that'd be your x, that would be your y, that would be your z. So let's say we were looking at the point 1, 2, 3. Okay, you would go over 1, up 1, 2, and then out of the page 1, 2, 3. So we'd go over 1, up 2, down. So that's over 1. Gotta make these marks over 1, up 2, and at that same we have to go parallel to the z-axis. It would be over 1, 2, 3. That would be the point in that little space there. So it's really kind of hard to picture. You got to think of it coming kind of out of the page at you. So if you're really good with visualizing three dimensions, awesome. You might be able to visualize some of this. Here's some good pictures that show these types of things. Okay, when we have an equation with three variables, it makes a plane. Think of that as a piece of paper. Okay, when you'd have three pieces of paper coming together all at one point, which is be this point right here that the arrow is pointing at, okay, that's where we get one solution. All right, right at that point is where all three planes meet. Okay, if we have a solution like this where we actually have all three of them meet in a line, all right, you think of it like a book. If it only had 6 pages and you kind of opened it up, it would look like that, and they'd all meet at that binding. That's the line where they all meet. So you would have a line where all three planes meet. Okay? And then down here, there's no place where all three planes meet. There's no place here where all three planes meet. Obviously, if none of them are touching at all, there's no place there where all three planes meet. So that would be a no solution. Okay, so let's actually try some of this. So enough with the visualizing. Solve a system of equations. So here we go. You need to take the first two and eliminate a variable, then take the second two and eliminate the variable. And we'll just use substitution and elimination to solve these and get to an answer. So let's see. If I take the first equation, if I'm trying to eliminate, let's say you guys don't like the letter z because it's new to you, so let's eliminate the z's. So if I multiply this equation times 2, this equation times 5, I will get my z's to cancel, so that would give me a 4x plus 8y minus 10z equals 36. Okay, if I multiply the second equation by 5, I get negative 15x plus 25y plus 10z, good, my z's are opposite, but the same coefficient. 27 times 5, let's see. 25 times 5 is 125 plus another 10, so that's negative 135. Okay. Add these up now. 4x plus 15x is negative 11x. 8y plus 25y is plus 33y equals 36, and negative 135 is negative 99. Okay, there's our first new equation that does not have a z. Now we need to come up with a second equation that doesn't have a z, and then we can solve that new system of equations. Okay, so this time I'll go in blue. If I want my z's to cancel again, I'm going to leave the first equation alone and just multiply this equation by 2. So I'm going to keep the first equation, so negative 3x plus 5y plus 2, whoops, that was a z, not a 2, plus 2z is equal to negative 27. Okay, I multiply the last equation all by 2 now. I'd get negative 10x plus 6y minus 2z. Good, they're opposite but the same number. Equals negative 34. Okay, now I can add them together. I get negative 13x plus 11y equals negative 61. Okay, now I've got my new system of equations, so I can line these two up. So I'll just write the red equation, or I'll write the blue equation so we have more space up here. Negative 13x plus 11y equals negative 61. Okay, if I multiply the bottom equation by negative 3, I'll get a negative 33y, and that would cancel the positive 33y. So that'll give me, let's see, a positive 39x minus 33y equals, let's see, 60 times 3, 6 times 3 is 18, so 180, plus another 3, 183. So this is a positive 183, and I'm going to add that negative 11x plus 33y equals negative 99 to that. Okay, when I add those, I get 28x equals, that's 84, divide by 28. Divide by 28, x equals 3. Okay, plug that in. I'm just going to plug it into the negative 11x plus 33y equals negative 99. So that would be negative 11, we know x is 3. Maybe I'll do this in a new color so we know I'm on a new step here. Negative 11 times 3 plus 33y equals negative 99. So that's negative 33 plus 33y equals negative 99. So add 33, add 33, I get 33y equals negative 66. Divide by 33, divide by 33, y equals negative 2. Okay, now I should be able to plug this into any of the 3 original equations and be able to solve for z. So I'll just use that top one. 2, we know x is 3, plus 4, we know y is negative 2, minus 5z equals 18. I want this whole page to move. Okay. From there, let's see, 2 times 0 is 6, plus, we'll just make that a minus. 6 minus 8 minus 5z equals 18. 6 minus 8 is negative 2 minus 5z equals 18. Add 2, negative 5z equals 20. So z must equal negative 4. Or just divide both sides by negative 5, we'll get negative 4. So my ordered triple, the answer, the point where these 3 meet, is at 3, comma, negative 2, comma, negative 4. Again, if I was to draw that on an x, y, z axis, x, y, and z, I'd go over 1, 2, 3 in the x direction. I'd go up down. Get rid of that little dash. Go down 1, 2, and I go diagonal, but in the opposite of the z-axis angle. 1, 2, 3, 4. So that would be where that point is. If you think of the z-axis coming out of the page, all right, this would be like into the page or in through your desk or in through the computer screen that you're looking through right now, would be kind of where that point is. So kind of hard to picture, but that is your solution to this system of equations. Okay, go ahead and hit pause and give this a shot and see if you can get to the right answer. Okay, the correct answer here, if you got this, pat yourself on the back. This is a killer problem. -6, 2, 8 is the solution. Bring in questions if you did not get that, which is probably a lot of you. It's hard. Okay. To test and see if there's, or while you're doing this and you go through, just follow that process. Take the first two equations, try to eliminate a variable. Take the second and third equations, eliminate the same variable so that you now have a system that just has two variables, and then use elimination again to try to solve those two new ones that you have. If during that process, the first two you get 0 equals 0, and the second time you get a line like 2x minus 3y equals 6, or something like that. If you get something like that, then they're actually lining up on that line, meaning that there's an infinite number of solutions that meet along that line. Okay? If you do the same thing, if you're using elimination, so if you're starting from the very beginning, use elimination to eliminate a variable in the first two, but you get 0 equals 0, and then you do it with the next two, and you get a equals b, like let's say we had, I don't know, 5 equals 0, something like that. That would be a no solution because at no point is 5 ever equal to 0. So it's kind of that same idea, just a little bit different. When you get infinite solutions, you're going to end up with one time getting 0 equals 0, or some number. Really it could be 5 equals 5, any number equals another number. Usually it's 0 equals 0. And then you get, when you eliminate the other two, a line. Alright, that's the infinite solutions. When you get 0 equals 0, and then a number equals some other number that they're not equal, that's the no solutions. Or maybe both of them. If you have nothing that, if they never cross ever, you'll get, like 5 equals 0 and 3 equals 0. So anytime you just get some number equals another number when that's not true, you can stop right there because you know there's no solutions where these ever meet. Okay. Hopefully that wasn't too hard. You're going to see that we're going to learn something with the calculator, so make sure you bring your calculator because on the next section it's going to be very calculator dependent. We're going to learn how to use matrices to solve systems of equations.